So this is the track that's called "Do We Really Need Yet Another Programming Language?" And I'd like to invite the people that are here. So Sylwia Brodacka, scientist who quit academia to change the world, works in Haskell to build Luna. And as we've all seen, I'm pretty sure everyone here has been in the last talk. Luna is definitely trying to change the conversation about what it means to have a programming language environment. Steven or Stefan? Steven. Stevie. Greg it is. So Steven did not quit academia, unlike some people. He is a researcher and lecturer at the University of Kent, and his research is also involved in understanding and rethinking the way we develop software. And I'm just going to read this off because I won't remember this. Recent projects include things like runtime type checking in C and C++, cross-language programming without FFIs, and the semantics of linking native code. And Marcin Kostrzewa, founder of Luna, he is a last-minute addition to the panel, so he doesn't get a good bio. He is a very vocal disciple of Haskell, and I think we'll just leave it at that. Should've. That's what you get, last minute, dude. All right, I'm Norbert. You know who I am because if you... Actually, you don't know who I am, because if you do know who I am, you'd be there. I have definitely a very strong bias towards list parentheses. I work in Clojure on a daily basis, and I have a love-hate relationship with types. And by that, I mean I love to hate them. So my suggestion for this panel is that we try to touch on a bunch of subjects, not get into a 1-hour discussion of why types suck. So my suggestion is that we try to keep our points very brief and to the point. Preferably, don't sugarcoat it. Just go straight for the jugular, right? Like, go straight for the thing that you feel most passionate about, and then we'll have an opportunity to do a couple, point, counterpoint, and then maybe try to move on to some other things. Does that sound good? So if someone starts rambling, I'm going to cut you off, but hopefully this will work. So just to get us all started off, I'm going to ask some little easy questions. So Steven, we have thousands and thousands of programming languages, and that's just the general solving ones. Now we're not even talking about like domain specific, just like embedded DSLs. In your view, why do we have, what is from a historical perspective, why do we have so many languages? Yeah, see, this is the part where I get to just talk.
Okay, it's on now. Right, why do we have so many languages? Languages are part of the culture. I think if you study computer science, we sort of revere languages. So everyone wants to make their own language. I think once you sort of learn how to write a compiler or interpreter, I think there's quite an urge to create, right? So that's one reason. I think people like to create languages because it's an intellectual exercise that they enjoy, and there's sort of an appeal in being the master of your own universe. But there's not that many languages that people actively use in large numbers, right? So that's the flip side. Obviously, we all know that it's good to have other people be able to understand your code and contribute to your code. So there's language barriers out there. So in many ways, you could ask, why don't we have more languages? Like, there's so many costs to adopting a new language that actually the number of popular languages at any time is surprisingly low. You could flip it and say we don't have enough that are actually actively used, right? Because often you're making a compromise. You're choosing a language not because it's the ideal one for you, but because other people use it, because there's a community, because there's tools, libraries, whatever. So I'm not sure whether it's true that we have lots or we have few. It's kind of an interesting question.
Okay. Well, we could actually just punt this to Marcin, because essentially you're part of the problem. You're creating new languages. So I want to know, without going into details about Luna, let's forget about Luna. What is the motivation for someone to go and say, I'm going to create a new language? Why would you do that?
It's just a part of research. We are in a very difficult field, and you can see that new languages pop out. And I believe that's because we still have a lot of unsolved problems, so we are trying to solve them. So we have seen a problem of languages being too hard to use and trying our best to make it happen.
You think that's a good enough reason to just go and create new languages?
Well, yeah, I don't think I need to explain myself. Why do I do things in my life?
So, Sylvia, why do we, from a developer's perspective, why do we bother learning new languages?
Because, well, it all depends on the fact what you want to do, like, actually. And when I was working with at the academia, like, the natural way was to learn the languages the rest of the community at academia was working with, like Fortran or C++ or C, but they were not like the best languages to use, even for the academian like modeling stuff, what I was doing. The best was Python at that moment, so I have learned Python because it was like better for the application. But then I still had to communicate with the other people. So in my opinion, you are learning the new languages first to be a better programmer, okay? So this is why I have learned Haskell, because I wanted to be the better programmer. And the second, because you have the problems you want to solve, and there are languages better for this problem and worse. Like writing Fortran code is not the best idea, never.
No, there's reasons, like money.
At the academia, no.
Okay. Okay, good. So those are, in your opinion, are the motivations for developers to...
For the developers, yes. Like two of these. Like you want to be better and improve yourself, so you are learning new stuff always. And the second thing, you have problems you need to solve and communicate with the people who are solving the same problems.
Do you guys agree, or do you feel there's different motivations for it?
I'm not sure I have a lot to say about that.
Then don't say anything. Let's change it up then. Maybe let's talk about paradigms, because well, functional programming. I'm not sure. Is it on the upwards curve or is it downwards curve right now? I'm not really sure. But there is more than just OO and FP, right? Wikipedia has something like over 64 paradigms listed. So I don't know, maybe I'll ask it this way. Are there specific niche paradigms that are interesting or have interesting aspects that you wish more people knew about?
I can answer that one for myself in that I feel like I never had a proper education because I never learned Prolog. And I think rule-based languages are very powerful, but they're incredibly hard to understand, right? So the way your rules sort of compose with each other is kind of part of both the magic and the pain. So yeah, certainly people nowadays start to call logic programming relational programming, because you don't just have functions, but you have relations and you can go both ways and so on. So that's kind of interesting to me. I kind of wish I'd learned it, and I still might. Yeah, I'm going to stop talking, let someone else talk.
Don't be shy. I don't know, Martin or Sylvia?
So I don't think there's, like in the general purpose scheme, I don't think we have arrived at a noteworthy paradigm yet, other than imperative versus functional. Of course, there's different flavors. There's object-oriented or not. By the way, I treat object-oriented as kind of a perpendicular axis to the previous ones. But in the domain-specific applications, like if you need a super safe system, there are like super safe languages, like modeling languages with very extensive type systems. There's relational programming, as Steven mentioned. So in specific domains, there's a lot to do. For general purpose, I don't think we have found anything other than imperative versus functional yet.
Well, if anything, it's imperative versus declarative.
We can say that. I don't really feel functional is declarative in the like full sense. It's still telling the computer what to do, not what to expect to do. It's saying that on a higher level. It's specifying the instructions on a higher level, but it's still kind of a recipe kind of list of steps to do.
So functional is a kind of imperative.
Wow. No, I would say I would just leave declarative for the domain-specific languages like relational or SQL or things like that.
I think one of the things is there's, I think Bosak, right, had functional program. He had this language, or functional language, I think it was called. And he basically separated between, because the way we talk about functional programming is we're applying values to functions. But there's apparently a different kind of paradigm where the functions are the things you work with, and then you apply a value to them. So you build systems of functions that have a single value versus something that we do both in functional and imperative, where we actually talk about the value of things, and the values and the functions modify values, not the other way around.
I mean, yeah, if you go like down the rabbit hole of how do you model functional programming, then yeah, you can do with basically three combinators, and you can go on from there. So on top of that, you can build a lot of different interpretations, but it's kind of the same thing under the hood all the time.
I've got a cheat list because I wrote down all the paradigms from Wiki, and we've got things like array-oriented, so that's probably like APL and stuff like that. We've got concurrent relativistic programming. I don't even know what that is. But declarative, it lists, it actually specifies functional as a form of declarative, contrast imperative. So you can go update the wiki if you disagree. But we've got things like,
just keep my opinion to myself.
Yeah, functional logic, obviously, constraint logic programming, data flow. We didn't talk about data flow, and you should have. I mean, you're almost doing data flow.
We are, but data flow is more limited in what it can do. So I kind of pushed that into the domain-specific category. Data flow is amazing for simple jobs, but it's not really that extensible. So.
Fair enough. I'm looking if there's anything interesting in here. There's a lot of stuff. Okay, screw it. Let's keep going. Sylvia's just sitting there. You want to add something?
It's fine. I'm just waiting for you. Like.
Oh, this has got to be a concurrency here. I can't be the bottleneck in this conversation. This will be terrible. By the way, I didn't mention it explicitly, but you know the drill. Like, if you want to write something, go ahead. Just there's no moderator, so you know.
I thought you were the moderator.
So be good. Like Mats would say, we're nice because, or is it be nice because I'm nice, or what is the Ruby one? Ruby developers, speak up. What is the Mats slogan? Mats is nice, so we are nice. Thank you. Mats is nice, so we are nice. I have so many gaps in my knowledge. Okay, sorry, I didn't take my notebook, so I just have this terrible phone. Okay, so I guess the question is, so we talked about paradigms. So do you feel that it's important to learn all these kinds of different paradigms, or is it more important to become a master of one?
I can answer that one. I mean, it's a boring answer, but I think that you can only improve yourself by learning many different ways of thinking about programming. And I think we were talking about this last night with Jarek, that one of the signs of maturity as a programmer is recognizing how much you don't know and how much room there is to improve. So programming is kind of, it's a craft that you can learn, it can take a lifetime to improve at. Obviously, we're interested in changing the curve so that you can get good more quickly. And I think projects like Luna have a really valuable role in getting people from who are not very trained able to do impressive things. But yeah, I think there's the more ways you can expose yourself to new ideas and new ways of thinking, the more flexible you're going to be. And even if you only stick within one language, right? Because there's so many different ways of realizing any given solving any given problem, even in one language. There's a great book, I don't know if you've seen it, it's by Krista Lopez, called The Elements of Programming Style, where she writes dozens of versions of the same program. It's some sort of like word count program, all in Python, but in totally different styles, where obviously in one of them she's sort of writing it like a Fortran program with lots of arrays and there's loads and loads of styles. And it's just really eye-opening. There's the number of different ways you can do the same thing. So the more you can expose yourself to, I think the better you're going to get. That's my maybe very textbook answer. Okay.
Marcin mentioned this, but I want to bring it up explicit. So we call them general problem-solving languages, but do you believe there is such a thing as a general problem-solving language, or are all the generic languages we build already specialized towards solving some domains better?
I mean, that's mostly driven by the community, but I would say yes, there is something like a general purpose language. And the best way to observe that today is looking at Python, which started off as a language for, I don't really know what. Like what was the original idea behind Python? I know they tried to make waves in web development at some point. They are kind of big with system programming and like DevOps, where Golang is trying to push them out. And now they started doing data science. And like 3 years ago, it wasn't really a thing. Like not that many people were doing data science with Python. Now it started happening. So this one language based on some principles, like this, the same actual engine is running all those different domains. So that's kind of general to me. But then it's driven by the community. So people, like enough people need to decide that we are going to use this particular language for this particular problem in order for that to happen.
Yeah, but you can't, for example, do concurrency well.
Yeah, you can't.
So doesn't solve all problems.
It doesn't, but it solves a lot of problems. So it's general in that way.
Okay. It solves all of the n as long as the n is less than all of m, where m is all kinds of problems you can solve.
No, so for me it's more about the design. It's more about what the authors had in mind when designing the language. So if you look at things like APL or R, you can clearly see that they thought about statistics from the very beginning. There's some parts of the semantics of the language that make it suitable only for statistics that don't even make sense for like web development. And then there's languages that don't make any specific assumptions about what they are used for, or they make them very, very subtle, like Ruby, which was created for data science and never used in data science again and became like the king of web development. So
counterpoint, there is a HTTP web server in R.
Okay.
No, but I think an interesting aspect of this, I find interesting, is that maybe we should expect languages to be more honest about it. Like if you go to a website, they should say that this is what we're good for. Let's not call it general purpose. Like these are the kinds of problems that as a community we've accepted that we should be solving. But that wasn't really a question, so I'm just going to keep going.
But this is about the libraries, not that much about the language. Like.
Okay. So do you want to talk about libraries?
Like, if you think about the Python, it is not like the people who created it were thinking about the data science at any point. So it was like enough really good libraries was created to do quite efficient work with the data.
Yeah, but at some point, the language as a design, for example, doesn't handle very large-scale multi-concurrency, just by design, no matter what kind of library you write.
Yeah, it does. Yeah, you are right. Yeah.
Back when it was created, like 20 years ago, nobody supported large-scale multi-concurrency, so it's...
Lisp is from the 60s, and it supports it.
Okay, Lisp is very good. Yeah, let's give it to that. It should have types, but other than that, it's also...
That wasn't fair. Lisp is not an actual programming language.
But can I just drill into that a bit more? I mean, why is it that you say Python isn't good? We know that the implementations of Python out there are not good for doing mega concurrent stuff. But what is it about the language that you're zooming in on when you say that?
That's true. On the one hand, and perhaps I expect lots of people have a one-to-one correlation with language to implementation. Right? And that happens very often. And it turns out that languages that then try to get ported into other runtimes, it turns out that there were a lot of assumptions that were baked in that weren't, for example, specified explicitly, but they actually were true. But even at a language level, if you, for example, if you say that you are a language that supports multi-concurrency, I don't know why we said, I started multi-concurrency, so I'm just going to keep rolling with it.
Right.
As there are no specific, for example, language constructs that say, this is how you would do multi-concurrency, right? Like there's no, at a language level, there's nothing that says, right, this is how we can create lots and lots of green threads or other kinds of things and make it easier. And here are some, atomic operations you can do across X threads and so forth, right? So like that's how I see it.
But that could be a library thing, right? I mean, in the same way that a lot of the data sciencey stuff in Python or R packages is not implemented in Python or R, right? It calls out to C and it does all the heavy lifting in there. So maybe you could do the same thing in Python.
Perhaps. Is it Python then? Is that like Python 4? It's not supported by all the other ones?
Yeah, because you're still expressing you could still be expressing your concurrent program in Python.
What is the essence of Python at this point?
I don't know.
Like, is it the fact that there are indentation and there's an equal sign? Like, at some point you have to say this is no longer Python.
if it quacks like a python, I don't know.
Point. All right, maybe. I mean, we can talk about standard libraries if we want, or maybe actually let's do something else. I want to talk about worldviews because I really like this concept that there are languages that build a sandbox. Like I think of the original Smalltalk. Like you have to do everything inside this environment. It's like an entire image. Common Lisp was like that as well. People didn't even know how to do source control with these languages because it would be just dump the entire image and send it to another server, right? And so there's this kind of application of this approach. And then there's like the Unix approach, which is you don't have, there's a language because there's a language specification, but really there's a debugger, there's an editor, there's a linker, there's all these different things, and they're all separate steps, and they're replaceable. And the way they communicate with each other is over some interface that we all agree to, whether it's sockets or just string text or something. And these are two very conflicting views, right? And the question is should we go in one way or the other way, or is there room for both? I feel like Luna also has this kind of weird place because you're sort of building like an IDE. It's sort of almost closed, but I'm not sure how much you're doing it explicitly and how much just by accident that it turned out like that.
So we are trying to be explicitly open, and that's just because we realize how big an effort creating a new programming language is, and we are not crazy enough to decide on recreating everything from scratch. So we just want to reuse as much as possible. So we are explicitly open about the stuff you can connect to, like creating CFFI pretty much 2 months after the first release. Now having the Python FFI in the works. We want to reuse as much as is possible. We need to fit in the existing ecosystem. On the other hand, there's like the freshest example of the opposite view. I think it's Elm, where you need to have like almost a written permission from Ivan to call into JS. And on his side, that's a very deliberate decision. And I think like we are moving across this trade-off of the ease of adoption and the pace of adoption versus how well thought out the whole ecosystem is. So for Ivan, the whole ecosystem needs to be very thought out and very like controlled, which will probably result in something that has great quality, but that will happen in 15 years.
So even examples like Smalltalk and Common Lisp, where they went from image to trying to split into components, is the idea basically dead? Was it just a bad idea that didn't pan out? This idea of having images, like having an entire ecosystems as languages, versus having these split tools?
So. No, I definitely don't think it's a bad idea. And I also contest what you said about there being a conflict between the two, right? Because even, so a Smalltalker or a Lisper would say, yeah, okay, we like to work inside the image because that's where all our good tools are and that's where, we actually get to code in the language that we like Smalltalk or Lisp. But there is still a process of building an image itself, right? There's a bootstrapping process where you actually, if you want to change certain core things, you have to step outside and build a new image. And so that is exactly the Unix style of development where you have to step outside your program. Or maybe step outside, because in Unix you've got this kind of idea of a file system. That's kind of what the image is, right? If you were to say in Unix, we've got this image concept, it would probably be the collection of programs, the collection of files in your file system combined with the collection of processes that is currently active. So I think it is possible. This is kind of a conjecture because it's a research question that I'm working on. It is possible to get the best of both, I believe. So I definitely think images are not dead. I think they're coming back very soon now. Well,
actually, you could. I suspect you could even argue Docker is the new image, because you could basically just have text representation. Like the thing you guys were talking about with Luna, right? That you have like this text-based thing that looks like Haskell, but you claim it's not Haskell. But then you have this big blob at the end, which just talks about how stuff is visually like graphed and stuff like that. So the question is, if you were just to do something like a Docker where you say that your language is not only the text representation, but all this other stuff, and maybe even running processes, and you can't separate that. You can't separate at that point. You have a problem with Git. You have to use something else, right? I think that's one of the problems with like this image-based system is that we're so focused on text-based representation that we don't really have the tooling for that at this moment.
Yeah, and again, it's the trade-off between the pace of adoption versus how much of your own toys are you building. Like, I don't want to build a new Git just yet. I may do that in 10 years, but I have much more burning problems right now. So I'm solving them, and I'm trying to reuse as much as possible from the existing communities and existing ecosystems.
Okay. So there were a couple of questions about runtimes. So maybe we can talk about that for a little bit. Languages, should they be hosted or native? Or should we be focused on making new languages or focused on making new runtimes, or like when should we, how should we make those decisions?
Sorry, still working. I basically think this is a dichotomy that we want to go away, right? We don't want to have this fork in the road saying you're going to be native or you're going to be hosted, because whenever you have, if you're hosted, it means you're contained within some box, and from being in the box you get some benefit, like you get the other libraries. Maybe you're hosted on the JVM and you get some whatever libraries are available, but you also get pain because the stuff outside the box, like there's other native stuff, and it makes it harder to get to that. So I'm yet to be convinced that there's actually that this distinction needs to exist, right? So I'm all in favor of unwrapping the box, making the box kind of no longer a box. I don't know how the metaphor goes from there. Yeah, it's a research challenge, so it might be impossible, but ultimately I want that distinction to go away.
Okay, but the other side of the coin is it's pragmatic and economical to use the boxes that were built, right? We've got 25 years of JVM experience that just went into building the JVM. We've got the Beam, right? Someone mentioned Erlang, I think, in the comments somewhere. So if, like, my ideal example is Elixir, because, so we're sort of skipping around, but we didn't explicitly ever say that languages, what is a language? Because at some point there's syntax and semantics and execution model, and I think all of those three things are separate. And for example, Elixir is basically saying we want Ruby syntax, but we want the Beam execution model, or the semantics of how Erlang works. And I feel that, so it seems like a lot of people are saying that, yes, we should just be reusing existing technologies that were thought out, right? I don't really know. I was hoping someone would just start saying no, but apparently, are we all in agreement that we should not build native? Or no, I know what you think.
I think at least me and Steven are in agreement that it's kind of a false dichotomy, and you just pick whatever tools work best in the current scenario. Like I wouldn't say if you are starting a new language you need to use JVM, or like you need to use anything else. You use whatever you want. Like again, in my example, in our example.
What do you want? What do you want?
Yeah, so I was about to talk about that. Using JVM, again, adds a lot of work for us, because JVM is not that great at creating functional languages. So I'm reusing, like at Luna, we are reusing the GAC stack, just so that we have kind of a functional assembler language, and then GAC can compile into LLVM and so on. So we kind of have best of both worlds. We can do machine code, we can do LLVM. But again, whatever you need for the actual language we are creating.
Okay.
You were asking about libraries, because this also has interesting implications for libraries. If you had built it on top of a runtime that existed, you would have had those libraries, and you wouldn't have that problem right now that you mentioned, that now you have to basically write all these libraries.
Yeah, that's why we are like, we have calls for C++ and reusing the best libraries we can, to not like create everything from scratch in Luna, because it is no point like to do this. So we are getting the Apache Arrow and the Plus and everything, and just apply it in this more functional way with better API to work with Luna better.
So you can reuse native libraries. It's not like it's not like if you are not inside the sandbox, you cannot reuse existing libraries. The native programs can also be shared, and this is, I think, most programs work this way right now, so it's not impossible.
Okay.
But you mentioned syntax, right? And I think that's a whole separate question. So, syntax has, on one level, it's trivial, right? So it shouldn't be an issue, and yet, it makes a big difference to people, because people find some syntaxes more natural, or maybe they've just seen them before. So I actually think that we should make it a lot easier to program in a syntax that you want, but divorce that from the actual language semantics, right? So I think that's a perfectly reasonable thing to want. Even stuff like, because we're still stuck with plain text to such a degree that how much time is spent on enforcing code style guidelines, because this project says you will have this many spaces and not tabs, and you will have all these rules. I just think, well, why can't we just make this sort of be automatically apply the formatting that you want when your editor is viewing the code? Just show it indented the way I want it, and then when I check it in, put it the way that the project wants it. If there needs to be some canonical form, which you could dispute, why should there? But I feel like syntax matters to people, and we should accept that. And then once we've accepted that, maybe we can actually save ourselves some pain by building some tooling, some more infrastructure that can deal with that better than we currently have.
So as like a side note, I think one of the best things that the Go language did was ship Go format as a default. And it's actually not a technical issue, it's a social problem that was resolved. Just all those hours of bickering over how syntax should look like, right?
But that's kind of bad as well, because it's forcing everyone to use one style. It's the one true style, one style to rule them all. Whereas actually, you want, if you value diversity, it's like we want people to, if they prefer their own style, then knock themselves out. But just ensure that the other person can see it in the style that they want. That's basically all this is about, like saying we don't want individuals to have to juggle different styles, because that's annoying for them. But it doesn't mean everyone has to use the same style. We can get more postmodern, say everyone has a subjective view of the world.
I am totally in agreement that we should separate syntax from semantics in these discussions, because they're two separate things, and I think the world would be a better place without them. But as soon as we do that, we have two things instead of one, and so there has to be an interface between them. And so who gets to decide what that interface should look like? And do you have an idea of what that interface would look like?
I'm still missing the abstract statement of the problem. Like, what is this interface doing?
You have arbitrary syntaxes that all need to be able to map to one runtime semantic.
Yeah.
So basically, they all need to map to one AST, like S expressions.
Right. No, I was exactly thinking, Lisp has the answer already.
Lisp has the answer.
But of course, S expressions are only supposed to be temporary, and then they kind of stuck around because no one built the tooling to actually present the nice syntax.
They did, actually.
Well, yeah,
I would argue against that. They did, and then it turned out that S expressions were better.
Well, I wouldn't want to see that syntax then.
You look at it every day. It's basically Pascal. But yeah, that's an interesting question. I'm assuming you are not Lispers, so S expressions do not come naturally. But can we maybe agree on a lingua franca for that middle layer? Do you think that's actually feasible in our community?
There's a question of how much anyone needs to see that. I mean, many intermediate representations are possible. So
LLVM?
Right, but how often do you look at LLVM bytecode as a day-to-day developer? If you're a compiler developer, fine. But I feel like you've only done the job well if the intermediate representation is hidden. So in that sense, we don't even desperately need to agree, right? We can have a small number of alternatives as long as we can interconvert. So yeah, I don't know. I just think we should have better tooling around syntax. And we should let people see the syntax they want. And I don't think that's even a technically that hard problem. I just think no one has done it and no one's got the community uptake, and everyone is quite used to this idea now of programs as text. It's pretty hard to make people think differently once they're used to certain ideas. So the whole dogma of we do have coding conventions, and we do have how much white space are you supposed to have here?
What's the main reason to change that? Why do you want to change the way people think, and in what way exactly? What's the reason for that?
Well, so for example, one of my reasons is I no longer use an 80 by 25 terminal most of the time, but some of the projects whose code I work with are formatted as if you do, right? So you want to. Sure. So it just that layout might work for some people, but it doesn't work for me. So it's really about it's about satisfying personal preference, maximizing my utility, so to speak, just about customizing things so that they work for me in the same way that I customize my text editor to have shortcuts that I like, and I have scripts that work for me. So it's the same idea as that.
So questions from the audience related to language popularity and sort of just having the language actually be used and picked up. How important are things like support in IDEs, package managers, and just community around that?
Extremely, I would say. Like, without this, you cannot gather the community. Without the community, you cannot create the living language. It will be just all that. So with Luna, it is even simpler. Like, without our own IDE, you don't have the visual representation, so it is obvious that we will provide it. With the package manager, if you want to encourage people who are less technical, like not the hardcore developers in basements, so you would like to do it as easy as it is possible to install new dependencies and work with the new stuff. As easy as like press the tab and import the library I need and install it. Because we want to give the programming languages to the people who are not really programmers before, so I think it is really important to get them here.
For any language, the biggest strength usually is the community and the adoption. It's is Ruby the best language to do web development, or is Java the best language for enterprise? Probably not. But it's used so widely that you have all those like external factors, like the availability of libraries, the availability of developers. If you are starting a new project, you will probably want to hire someone for that project at some point. So starting a new project in Haskell, well, it's a risky idea. So the community is the most valuable thing a language can have, and it trumps every technical aspect of that.
Yeah. So basically, when you design programming languages, you should treat community and package management and IDEs as first-class citizens.
Yeah, definitely. You need to design around the fact that you want people to actually use that thing. It's just like programming languages are just products at some level. Like they are products for developers to create stuff with. So things like user experience in a programming language and the whole ecosystem matter a lot. I want you to be happy when you use the language, and this is I think this is the case with many other languages, like most other languages. The biggest success is where the best user experience is.
If I could, I basically agree with most of that. But when you mentioned build systems, I couldn't help but jump in on that one, because I absolutely hate it when a new language comes along and wants me to learn a whole new build system. I don't see the need, and package management is the same. Now I have this huge layer upon layer of package management, all language specific, which isn't even good because you can't track dependencies across languages or cross, outside one package management system to another. So I think it's a case of locally good but globally bad, right? You can see why people invented them because they solved a short-term problem, but actually there's a bigger problem, which is integration. How can we actually make it possible? So I would love it, I use Linux, I use Debian. I would love it if everything was a Debian package. Why isn't that possible? Lots of answers, right? But
Needs to like make it even better or worse. I don't know. It depends on which side you are. So.
Sorry, I missed the beginning of your answer.
I told that they brought Nix, so the Nix package manager to like make them all.
Right. So
unique and.
It's definitely, as a researcher, I find it odd that there isn't a very active research community on the problem of what I would call software build and deployment. So build systems and packaging systems. I feel like so much human time is spent wrestling with these things, and yet we don't revere those systems in the way we revere languages themselves, even though they're every bit as important. And I meet people who are very smart programmers, often sort of researchers, so they're like Ace Haskell programmers or Camel programmers, some highly skilled sort of people, and yet they don't know how to write a makefile, and they write the most atrocious, horrible stuff that I then have to fix for myself. So, yeah, I don't know why this happens. Like why we consider build systems to be this kind of subservient thing, and it might be that just we haven't built a really good one yet that can really capture a wide spread of requirements. I hope that we can make some good progress on that soon. And I think it's not going to be by each language doing its own thing.
You want to react?
Yeah, I just want to say that I completely agree with that. And yes, we need a standard for package managers. And I don't really see the need for them to be language specific or platform specific. So we could make something general there. It's not there, and it's super painful. And basically, whenever I come to a new project, I spend 3 days just trying to make that thing work. And that's the worst 3 days of starting any project. So yeah, just 100% agreed.
Yeah, but Marcin, you're at a position where you can make this happen. You can go back to work tomorrow and not make a package manager for Luna.
I can, and maybe not tomorrow, but I will at some point, or someone at my team will. But anyway, I would like that to be a standard. I don't really feel the need to design it from scratch. So that's a problem. And I think this is what Steven was pointing at. Like there should be something already designed and reusable for that particular problem.
Yeah, but now if you do it, there's going to be another package manager. The question is, how can Luna work without doing that?
No, it can't. So I will build the package manager. I'm just very unhappy about that.
You heard it here first, folks.
But maybe the alternative is to say, well, we support a few different platforms. We can't unify. So often, it's too hard to unify, like fix on one standard, but you can say there are, 2, 3, 4, 5 different systems that we can target, and we do the n squared thing where we worry about how do I integrate into this one and this one and this one and this one and somehow bridge the differences. It's a lot more pain. So the quickest thing is always to roll your own that solves your immediate problem, but maybe the right thing, we always have this choice, don't we? Like, do I do the easy thing or the right thing? And it's pretty much economic incentives that force you one way on that one. So maybe this is the role of, this is why we need not just research, but I get frustrated that it's really hard to transfer technology into production, and there's not enough. I feel like in the private sector, you are forced down this route where you do the thing that gets you the quickest return because it's a very competitive marketplace and so on. So I think this is exactly the role that academic research and the technology transfer that comes out of that, we should be tackling those hard problems. And that's why I find it doubly sad that build systems don't get much attention. So I would like to, it's kind of a political issue at that point. Is how do we make innovations happen in a way that they can transfer into practice and tackle these really hard problems that in the private sector probably not many people are in a position to spend many years on a thing that is only going to come to fruition after lots and lots of person years of development time. But I think we need some section of society that is working on that. And currently, academic research doesn't really do it. So we need to change that somehow.
So Stephen for President 2020. But in the meantime, we need to roll back. It's been really fun talking to you guys, but we're slowly running out of time, and we have not talked about the elephant in the room, types.
Bring it on.
We need, who here can do a 30-second explanation between static, dynamic, weak, strong, soft, gradual? I want everyone in this room to leave with an understanding of what all these words mean, so we can have a sensible discussion on Hacker News later.
Okay, weak and strong don't mean anything, so we can cross those off straight away.
Yeah, they do. Discuss. Marcin?
I'm very bad with those categories. It's just every type system is a bit different. Some are good, some are not that good. And if you Google those categories, you cannot find a definite answer. What's the difference between dynamic, weak, and
let me try.
Okay.
Let me try, and then you can disagree with me. So the way I see it, static, it's at compile time. That's all it means. It just means that we checked types are self-consistent at compile time, whatever that means for that specific language, for the capabilities of that language. Dynamic is that you check at runtime. So that's the only difference. Static versus dynamic, is it at compile time or is it at runtime? Weak is you allow values that are theoretically different types, but are treated as one. So you treat, for example, an integer as a subclass of number, and then if something's an integer, it's also a number. But theoretically, it's not the same type. But for some reason, you can, for example, weaken the value of what those types mean in a specific language just for comfort.
I don't understand that. What do you mean? we can. Is this about coercions, like implicit conversions?
This is exactly what I'm saying. I'm saying that if the language does an implicit conversion, it's a weak sort of typing.
So Java is a weakly typed language.
No, Java is actually soft, but I'll get to that. So strong is the exact opposite of weak. If it's not weak, it's strong. That's all it means.
Which means you cannot coerce types up.
Which means you have no implicit conversions of types. You need to...
Okay, so it's implicit. Okay.
It can't be implicit. Implicit means it's weak. And explicit is where Java comes in. So soft means that you can explicitly do... so soft is Java. Soft basically says that theoretically it's all nice and statically typed, but at some point you can just do casting that's arbitrary. Right? So you can just say that this is now going to be a completely different type and try to disagree with me. Maybe you'll throw a SegFault or something, but I'm casting this to a different kind of type. And then gradual is, for example, when you have a mostly dynamic language, but you can be explicit about certain things. You can explicitly set some types. So for example, closure I see as a gradual typing. Everything is dynamic, but you can explicitly set that these are specific Java types, for example, that should be here. Usually this is just for performance reasons, right? A CLR is like a reverse gradual because it's mostly static, but you have that weird dynamic thing where you can explicitly say that something is dynamic.
So wait a minute, does this mean Java is gradual because I can, if I want to write in a style where I just declare everything as an object, I can do that, and then I put casts in where I want to say, oh no, this is really a string or
no, Java
whatever.
is soft because because as soon as you can cast anything to object, it basically means nothing anymore, right? Because the kind of once you cast it to object, then you cast it back to something else. Your type system can't say anything about this, even at runtime. I mean, at runtime, the best it can do is just crash.
Like, no, I mean, it can either it can check dynamically that it really is of that type. If so, continue. If not, some sort of exception.
Mm-hmm.
So, sorry, can you say again where you put Java in your taxonomy?
In soft.
Okay,
So
but I don't understand why it's not gradual.
Gradual would be that the things that are the things that you make dynamic, they don't change in the runtime of a single instance. Let's say that, right? So like, you dynamically figured out that this thing is a string, but it's not going to end up being something else later on during that single run. Because once you start doing like the kind of casting you can do in Java, is you can actually later in the same runtime something that the compiler, at runtime the compiler thought was already a string, now you turned it into an int, and then you try to do operations on it.
When would that ever succeed?
It wouldn't, but it would crash hard, where the point of the types was to say that we shouldn't allow this, or we should tell you that this is something you shouldn't be doing.
But that's just a dynamic version of, I mean, if you get an exception saying that's not a good cast, isn't that telling you, albeit dynamically, it's telling you that you shouldn't do that?
Yeah, the question is, will it tell you that's not a good cast, or will it say okay and then SegFault? I think I'm pretty sure old versions of Java would do the latter.
No, only there was a famous bug to do with class loading, but apart from that, Java has always had what I would call, what would I call it? Dynamic type safety. Dynamic safety. Yeah, it doesn't crash. It gives you a clean exception of some kind.
Mm-hmm.
There was a bug with class loaders in the original design, but that was, I mean, there's already a bug, right? Because you know that Java static type checking is not sound because of nulls. You read that? Okay. So there's always bugs, or potential for bugs.
I would just say this doesn't sound like a very helpful division, like a very helpful categorization of the type systems. Like if you really go into that, there's much more interesting things that you can say about the types. And I feel like most languages today, they probably don't even like fall into those categories anymore. It's just it's kind of artificial. I mean, like this probably describes well like the times where we had 4 languages at the table, but now it's thousands of them, and you really, like if I described my type system as a strong, weak, like, okay, I don't know, dynamic, weak, soft, pink typing, that would probably not help anyone. So I would just say, just describe the type system in using English.
So how would you describe Linux type system?
Okay, I would say it's a static type system. It's compile time checked, and it's a semi-dependently typed system, and it's also the way I describe it usually is like static duck typing.
And that's more clear.
Yeah, if I say static duck typing, I would assume that you have used a duck typed language, and the static part means that it's compile time checked.
So you mean it's structural checking?
Yeah, on the.
That's probably a nicer name.
That depends on who I'm talking to.
And semi-dependent?
Yeah, let's drop that. That's for the nerds. That basically means that values can be parts of types. So you can, like, the most famous example is that you can have a list that has a certain number of elements, and it's hard-coded what number of elements that is. And you can do things like append, and the type checker will automatically update the type representation.
So why are types important?
Because they bring you information. First of all, they ensure that you are not doing very stupid things. So like you can cut the number of tests that, like, back when I was working with Ruby, I would always have like just half of my test would be checking the contracts on all the objects. So this is something that happens for free in a statically typed language.
Right, so you're talking about static typing, not types in general, right?
Yeah. Yeah.
Just to be clear.
Yeah. So that's something that it gives you, and also you get better support for the for the tooling. You can have better contextual hints and so on and so on. So the question really for me is how helpful that system is and how constraining it is, and how much overhead there is coming from that system. Because if I need to write everything manually, like if I need to type every single definition, that's not that helpful. That's just a lot of overhead for a very marginal return. But if the type system is not that annoying, then it just is there and it sits there to help you, but without the whole pain of being in a statically typed language.
Okay, so
yeah, exactly.
But okay, so now you compared it against Ruby, but now you're basically just talking about the fact that the types are implicit. You don't have to type them out.
Yeah, that's one of the factors that helps. The other factor is that how many different things can you express in the type system? How many times in Java you have to do an explicit coercion just because the type system cannot handle something like cannot handle a heterogeneous list, things like that.
How many times in Luna do you have to write an if check because you don't have dependent types? Like you can't say that this list can't be more than 4 elements, or this integer must be between 1 and 32.
Yeah, at which point you have to probably escape that framework and just not use it in that area. Or like if you don't know that your list is always of the length 32, why did you use a dependent list in the first place?
No, but like for me it's arbitrary, because if you're going to say that the types help you and your specific type system doesn't support this kind of representation, but others do, right? Ada does. Why aren't we all just writing in Ada?
Do you mean Ada or
Ada, sorry.
Okay, to avoid confusion with Agda.
Yeah, Ada, sorry. Well, because Ada has those dependent types, and you would be able to specify that this integer must be between 1 and 30.
But I think you're confusing two things, right? I think there's two different things going on here. One is any language, even if it's dynamically typed, even if it doesn't have any checking at all, right, potentially, has a language of data types. So there's a thing, it's basically a language of abstractions. You can write down, say there is a thing that is, maybe it's structured, so it has a field, it has an int field and a float field or whatever else, or it's like an integer, but it's only in these values. So you've got some language of abstractions that you can write down, and there's value in just writing them down, right? It helps you express your program, because then you can talk in terms of these things that you define separately, so it avoids you repeating stuff, helps you keep the code consistent. And that is totally orthogonal to the issue of checking and when to check, and even what to check.
Mm-hmm.
And that's the thing. So when people say type system, sometimes they're talking about the first thing. They're saying, how rich is this little sub-language inside my language of these sort of data abstractions that I can build? And sometimes they're talking about the syntactic rules for checking at compile time, that you've formed your program in this semantically, provably type-correct way. But for me, the interesting, there's a property of executions, which is the execution type-correct? And everyone agrees that that's a good property, because if an execution is not type correct, it means your program is doing something meaningless. But exactly how to establish that it is type correct, there's a whole universe of possible ways of getting assurance that your program is type correct. One of them is this syntax-directed checking paradigm that we've had since the 70s. I do feel like basically all the paradigms of our field were set in the 70s, and then we've kind of just rolled with them since then. I mean, there's a lot of sort of inertia that was developed during that time. So doing it by syntax-directed checking is one thing. Doing it at runtime is another thing. There's kind of a spectrum. I don't think it's properly explored, that spectrum yet.
I totally agree with you, because I'm just somewhere in the area where I like the stuff to be in the runtime, because I feel that I just have more control over the kinds of things I can check versus the explicitness of how much information I would need to give the compiler at compile time to do those same exact kinds of checks.
But it's also a question of how much information you can give to the compiler. I mean, like let's move away from the like traumatizing type systems of Java, for example, towards Haskell, where type system is a tool that works for you. So, for example, like the whole thing with meta programming in Ruby, or like template programming, you can do a lot of that with Haskell, just writing smart type signatures, like type expressions in the language of type families or type classes, because you can actually generate code. Because you have a language that's interpreted compile time, you can actually generate runtime code compile time using types.
Or you can just write a predicate.
No, you can't. I mean, you can generate, for example, I don't know, a lookup table for something, or like specialized versions of your functions just using the type systems. So you can cut out the if altogether from your runtime code. You can write something that's much more performant just because you specified that on the type level system, which is like also brings me to the point of types enabling much better optimization, like actual types, not Java types.
Isn't the answer to this Lisp macros? Don't you want to say Lisp macros?
I mean, I know the answer, but I promise not to talk about Lisp to the organizers. Because I have a solution. It's just I can't figure out why you don't see it.
This is the blob paradox, right?
This is the blob paradox, exactly.
Let's put that in parentheses.
I think we need to start rolling, like finishing up. I don't know if they're just going to kick us out at some point. Why don't I just leave it up to you guys? Do you guys like want to just say something, leave on a happy note, tell everyone to go screw themselves, whatever, you know.
On a happy note. Okay. I think we do need new languages, which is like originally the topic of this panel. So we do need new languages. Sometimes they suck and then we don't need them. So that's kind of a research area. And yeah, let's just be open to that thought and let's use types.
And I would just add that there's a sort of, the whole question of the panel is kind of loaded because it's sort of, do we really need a new one? It sort of implies that there is a cost to new languages, which is absolutely true, right? That we can't just invent new languages willy-nilly and not pay anything. So I think there's a separate dimension on which to tackle this, which is to reduce the cost that new languages impose on people, and that's partly through not having onerous kind of FFI things, finding better ways of doing that, which is a topic dear to my heart. But I'm sure we can think of lots of other things. So in a sense, new languages are great, so let's actually make it easier to adopt new ones, to have old ones and new ones coexist, and to just make the evolutionary process sort of go more smoothly. That's another topic I think we can make a lot of progress on.
I just hope that at some point there will be like evil genius who will just change it all and bring some totally new idea which will like help people and achieving their goals in a totally new way. So I think like there is the whole future in programming languages that we will get. Like with completely new approach, maybe connecting to the old ones, but with different.
Also, quantum computers are coming. So
yes, exactly. Exactly, yeah.
Quantum computers are coming. Okay, so I really don't want to have the last word because I feel that what you've just said is a lot more important. So let's just end it here. Just cut it off. Thank you all for coming.
Thanks.